Before I started today, I just want to make two quick announcements. Number one, this morning during the office hour, I actually record all the content because there are questions related to both homework 1 and homework 2. And I kind of give a general introduction. I actually show, just let you know, I give a really quick tutorial on makefile. And because there was some issue related to the makefile. And number 2, I show how to debug segmentation fault using GDB, GNU debugger. So that's actually address a few things, meaning why you will have segmentation fault and how do you actually quickly locate where it is. And also I show a little bit about the installation and the problem related to the JSON CPP library. It's about installation. I mean, I actually found out the student, some of the students, you actually install the JSON CPP library, everything is correctly, but you need to add certain line, especially -I and -L for your makefile to work with that installation. Unfortunately, different environment, even with MacBook, you have a 2 different installation depending on whether you are ARM 64 processor MacBook or your Intel MacBook. They're actually going to be in 2 different locations. So we have like 3 different kind of JSON CPP installation. So that's why you have to figure out using the command called find, which I actually show how do you use find in that video, that you can actually find out which environment you're in. And so you can actually change your makefile appropriately. Of course, when the TA try to grade your homework, they're going to deal with the same issue. So typically, the TA will already have 3 different lines there with the LD flag and with the include flag. So we will actually be seeing that which one we know which one is going to be appropriate to the environment that he will be grading yours. So it's very easy to just actually change your makefile to that particular environment he's in. So you don't have to worry about that. As long as it works in your environment, that should be no problem. Okay. The number 2 announcement, very briefly, I didn't even send out the announcement, is that I update the code because on October 24th, I give the code which says homework 4. I already update everything to be homework 5. Okay, and also this file, I talk about that. Oh, this one I should delete it. Is actually now everything is homework 5. But I also include this program I mentioned. That's actually talk about some of the facility function, like how do you actually handle JSON from file to string to JSON. Everything has been updated and tested, so you can actually see how it can be done with the, by the way, the whole program over here, you can actually integrate make. You might need to actually change the makefile because of that environment issue. Okay. So right now, I'm actually going to PowerPoint, my PowerPoint slides number 7, number 8. Let me just give you some idea about which section we're talking about. So I will be starting today talk about the concept called smart pointer, and then I talk the rest of the virtual function, the smart pointer, virtual function, and pure virtual function. Those are cover the chapter 13, 14, and chapter 5 and chapter 6. All right. So, and the main focus will be actually chapter 13 and 14. But the concept of smart pointer is something which is kind of useful for you to actually know the reference count. And the next section, I'm going to start after I'm done with 7. I like to really go into 8 as soon as possible. Number 8 is about exception. So now the core chapter for the object orientation is 11, 12, 13, 14. But 15, we start to talk about how do you actually handle the chapter 15, which is a very important part of the C++, is how do you actually handle exception, the runtime unexpected situation. And this is really useful tool. I mean, it's not really related to object-oriented directly, but it's a object-oriented way of implementing how you can handle exception. And that's actually going to be in chapter 15. You can start look at this. We will be seeing a lot of this kind of exception. You actually already see some of the example when we get into JSON RPC CPP. They're using this kind of exception everywhere. Okay, that's the master plan for today. But I hope I can. First, my goal is try to finish the smart pointer stuff. Okay. Okay, so pointer is one of the relatively challenging concept in the C++ programming. And we covered this topic, I think, last week to talk about in C programming language, address, pointer, reference, and array, and plus the mechanism of casting. They kind of bundle together as a cluster of concepts. They're really related to each other. And sometimes as a C programmer, I think it's important for you to not only understand each of the concepts individually, but understand how this concept can translate to each other. And to understand this concept, how they will link together, you need to understand also about the memory layout, because really that differentiate C programmer from anybody else is you actually need to a lot more aware of the existing of the memory layout. And the thing is that, for example, today, if you watch the video, it's very interesting that there was apparently a memory layout bug or segmentation fault. And that bug didn't show up. I still don't know the answer. That bug won't show up on the MacBook. My MacBook, when I run it, no problem, correct, homework 1. But when the student try to run it on WSL, it is a bug. So we still don't know. And in my programming career, that actually happened a lot. It means that C is actually vulnerable to the environment you're in. Python is usually not. Yeah, you have what? Oh, Windows subsystem for Linux, which is a Linux environment. So because I haven't found any student in this class is using a pure Linux environment. So everybody, when we talk about Linux, we're using Linux on Windows 10, which is WSL, Windows subsystem for Linux. So it's quite interesting. At one point of the information technology development, that Microsoft and the Linux community, they're almost like they want to kill each other. It's more like Microsoft really want to kill Linux. That's the rumor saying that. Okay, saying that, well, they really think that Linux is going to be a threat to the Microsoft, the dominance in the Windows market. But then at some point, they realize they're not enemy, they're actually friend. So they're actually supporting each other. And so it's Microsoft's credit that they actually developed, probably, in my opinion, the best lightweight virtual environment for Linux, which is WSL. So it's interesting that the development of the technology in terms of operating system, because now we're more in the app layer, application layer, in the operating system layers has been kind of done in that sense. Yeah. So, okay, thank you for the question. So the thing is, I want to make sure that you're aware that the C programming language is indeed need to do that. And the thing is that you need to know a little bit about memory layout. It's different, vulnerable to the environment. And sometimes you will have, oh, today I actually mentioned the other term in the recording. I actually differentiate this three kind of error: syntax error, runtime error, and logical error. So let me actually just briefly using homework 1, what's the difference among the three errors? If your program cannot compile, when you type in make, they give you a lot of, say, syntax error, meaning that you forget a semicolon, or you forget a bracket, you forget a double quote. That's actually make sure that the compiler cannot actually produce the executable. Then that's actually all into the syntax error. So runtime error is when you actually have executable, no problem, no error, and you run that program, which means that the program is being brought into the memory layout. And the thing is that it's causing things like a segmentation fault, means you access the wrong part of the memory. That's what we call runtime error. I mean, the concept is important because a lot of this exception handling, which is in chapter 5, is actually in some sense dealing with both runtime error and logical error. You will see a lot of those between these two. And what's the logical error? Means that your program won't crash, means there is no segmentation fault. But in Wordle.c, based on your logic, you should always be able to find a solution. But then you actually realize your program, for some reason, cannot find the solution, which is not causing any memory layout problem, but is actually not giving you the right answer. So that's what we call logical error. Okay, so the syntax, runtime, logical, we all have to deal with. Okay, so that's actually the pointer. We covered that. It's a really hard problem. I don't expect any of you be perfect in this kind of concept, but gradually, when you write more program, you encounter more segmentation fault, like what you did in chapter 1. You will eventually be an expert in taking care of that. Especially tool like a GDB is very useful for you to actually handle that. There's other tool as well, but I'm not going to cover that. It will help you to very quickly deal with any of the runtime error. So we're going to go into this topic of smart pointer. Let me be brief about smart pointer. It's kind of motivated by the runtime error. Why is motivated by runtime error? Because the number one likely error that we had in the C or C++ programming runtime error, I mean, is dereference a null pointer. So meaning that, I thought this pointer should be gone, so I just get rid of it. And so, in other words, that's actually going to be say, hey, it would be nice to have a way to keep tracking how many reference to that particular pointer is still there. If there is a one reference pointer still there, then I shouldn't remove. I shouldn't actually call the function free or delete. You can think about, for example, you use new, and then you wonder whether I have already cleaned it up. You actually can also check whether the reference count is actually go to 0. This is, I feel this is like motivated by a concept that first, well, I shouldn't say first, but adopted by Java. So Java doesn't have this kind of traditional C pointer. All they have is a concept called garbage collection. So what is a garbage collection? So if you have a piece of resources, if there's a no pointer that's actually can reference to that resources, then I would say this resource is garbage. I should actually collect it to throw away, to reclaim the memory, the resource. So that's called garbage collection in the, I mean, the name sounds bad. Actually, I feel it's kind of a bit of a, not so appropriate. It's a name for technology that's really trying to help us to clean our memory, but that's traditional, we call garbage collection. And that's the idea, is that any resources, if you don't have any reference, means nobody has any remote chance to access that piece of memory for any reason, then that piece of memory should be free. And that is a really, really fundamental rule about where a memory should be released. So in C++, they come out with something called smart pointer. And the idea, unique pointer is basically just a regular pointer. Unique pointer is just regular. But the share pointer is that, okay, when you have a pointer that's a share pointer, it's essentially create a counter about how many variable has remembered the reference to this share pointer. So that's why they can know that how many counts you have. And in that case, that they can actually access to that. So they can actually count. And the weak pointer is kind of hybrid. So weak pointer is also can use the share pointer as a reference, but it won't be included in the count as share pointer. In other words, that you could have a pointer has a 5 share pointer that's pointing to that. If this 5 is gone, then this pointer is gone. But then you could have 2 other weak pointer also pointing to the same resources, which if it's gone, that's your business, it's not mine. That's called weak pointer. So C++ have this concept. I'm going to show you very quickly about what it is. Okay, let me look at the example. Let me directly show you a share pointer. Okay, so this is I create a share pointer XP, which is basically create a it's an integer pointer. I use new to create an integer initialized to be the value 222. And then this is a line which share pointers start to play. Is I actually create another share pointer. This is a syntax. Is share pointer is just say share underscore PTR, and it's a pointer to an integer. You have to provide a type of that pointer, and then you just basically copy the value over here. So by doing this, the share pointer is going to have a count that you can access that this one become 2, the value of the count. So let me actually show you how you can do that. So essentially, what you have is a reference count looks like this. This is an object-oriented structure that you not only have a pointer to the object, that's the resources, but you also have a pointer to what we call the control block of the share pointer. Control block is contained information about how many share pointer are pointing to this particular resources or object. So in the code, you can actually use this called use count, because XP is a share pointer, so you have a member function called use count. So use underscore count is actually giving you the number of reference that's currently going there. So this is actually a significant improvement than the traditional C programming. Traditional C programming, if you don't have the share pointer, you just have a regular pointer, you have no idea how many variable has been pointing to this one. But now with C++, we have this share pointer, which really allow us to be able to track this. So at least you can actually, when you have a problem we call memory leak, then you will be able to quickly understand, oh, wait a minute, how come my share pointer, the use underscore count is not 0, where I thought it should be 0. If it's not 0, means that, oh, I thought I already cleaned everything, but apparently there's one place I forgot to delete, I forgot to remove, and that's why the count is still 1. So it's basically being tracked. Okay, the share pointer is a tool for us to track whether the pointer is being used. Okay, so we have a reference count. So what's a share pointer? The share pointer is basically has a pointer, but with a reference count over there. And then what's a weak pointer? Let me actually show you an example of a weak pointer. If I define something as a weak pointer, the syntax, you just say weak pointer, okay? So you will realize that when you do share pointer, if you run this code, that the use count, when you actually do the first line, this line, when you say xp2 is equal to xp, assign, xp being assigned to xp2, the use count is going to increase by 1. When you do this code, and you can actually run this code by yourself. So here, the value here is supposed to be 1. Over here is going to be 2. But when you actually do a weak pointer, when you actually print the things, this 2 will be saying 2, because weak pointer doesn't count as a reference increase. And then you print the WXP use count is also 2. So basically, it's just an observer. It's a read only. Okay, let me just repeat it again. If you write a program, you can actually see, use this program, you can see the difference. Essentially, weak pointer only witness the reference count. It provides you as an entry reference, which is in the debugging is useful because I can see that I have a weak pointer to this resources, but now I can see it's a 0. Okay, when you delete both XP and XP2, then essentially this one should get 0, but which means that you still have a pointer you can print the result after you delete the other 2. So that's the very important usage of a weak pointer. If you don't have a weak pointer, you cannot print it anymore because once you clear it, it's gone. Okay, so that's why the most useful place of weak pointer, in my opinion, is kind of debugging or kind of realize that this is something you really can get rid of. Okay. All right, so that's pretty much I handle very quickly the smart pointer. This essentially is a diagram for your homework assignment number 4, which I start talk about on Wednesday. I'm going to skip this part, but I want to directly talk about the next thing before I finish. Chapter 14 is called pure virtual function. So the syntax of pure function, as we see that on Wednesday, at the code, looks like this. I define a virtual function. In this case, I define a function called volume. And this volume, after I define it, I put the equal to 0. So then when I put it equal to 0, this actually declares that this function over here is a pure virtual function. Let me actually show you the code. Oh, maybe I should show you this code. So this is the virtual function, looks like this. And then I define another inheritance, a derived class called box. So class box is a public vessel. But then here you see that I have a virtual double volume. This is a virtual function, but here I actually provide implementation, and I didn't say equal to 0. So this is not a pure virtual function. This is the real virtual function. And this one is the pure virtual function. So first, I want you to know the syntax difference. To say this is the pure virtual function is actually you see equal to 0. At the end of the function declaration, it doesn't have that. Okay. So now I want to tell you the difference between virtual function and real virtual function and pure virtual function. So a pure virtual function is really just provide a specification of the interface. And it basically mandates that every single class that derive from this interface class, they need to provide an implementation for that virtual function. So this is essentially mandate that everybody below me has to have this virtual function. I mean, for example, I want you to implement this function dump to JSON. I want you to create this function called dump to JSON. And I said every single class has to have that. And what I could have done, I said, okay, every single class that you created has to inherit from a particular class. I call that class, say, ancestor. I call that ancestor. And in the ancestor class, I actually create a virtual dump to JSON. I create that object, but then I put an equal to 0. So that's equivalent to asking you saying that, hey, every one of your class has to inherit from this class, which means that you have to have the function dump to JSON, because this basically say, when I define this, everybody inherit from this class has to have this function. And the thing is, not only that, but this one is a pure virtual, means that it's abstraction. It's just an interface. So it means that all the derived class has to have their implementation. If you don't have that implementation, the compiler won't let you go, or the linker will let you go, won't let you go. Yeah. Okay, good question. The question is, what happens if I actually do the class vessel, right? So number one important thing is that once you have a class that has a virtual function, has a pure virtual function, you cannot create an object from this class, because this is just an interface. It's not a real class. It's an abstract class. Abstract class means I cannot create one. So you must create from one of its derived class. So in the virtual function, it will actually go to that particular class. Does that make sense? Yeah. That's an excellent question. I like that. It's very important that if you have a one function in a class, that's actually pure virtual. You cannot create any object. You can try. You can do a new, and the compiler will actually fail. So yes, in the back. So you're saying that I can have a parent class which has a virtual, and then has a derived class also has pure virtual. Yeah, I think so. Yeah, you can have a multiple. That means both of them are interface. Yes, that's definitely doable. Yeah. Okay. Okay, that's called virtual. So let's actually take a look at the code I showed you the other day. So hopefully that will make sense right now. So this is the program. Let me actually use my window. It's probably better to do that. Okay, this is the same code you have in the GitHub. The reason I have to use this window is because I didn't create HW5 client.h over there, because it was supposed to be generated. So you can see when I make a clean with this make file, I remove HW5 client.h, which is that file is this file. Both this file is actually automatically generated. So when I clean, I always remove them. All right. So I'm going to make again. So you can see that it's the first one is actually make using the JSON RPC stub, which is actually create those two classes. So okay, let's actually look at HW5 client.h. So this is a program that's generated, and you can see the function dump to JSON. Hold on 1 second. Sorry, not this one. The pure function is in HW5 server.h, not client.h. Yeah, client.h doesn't have the virtual function, but the server, yeah, the server part is the one. So you can see that the server HW5 class it actually inherits from an abstract server. To go back to your question in the back, inside the abstract server is already pure virtual. It's already a pure virtual, is abstract, but they actually create another derived class called HW5 server, which is also the virtual. When you have this function dump to JSON this function that was an inline. Here is a dump to JSON, and it actually has the function equal to 0. So which means that they're saying that, hey, you cannot use this code I generate directly. You have to have a code which is inherent from this code. And then based on that code, that you're going to implement this function. If you don't have this function implemented, then I will say this pure virtual contract is being violated. So essentially, it's not just specify the interface, but it basically mandates everybody in the derived class has to have that. So let me try to play a little bit tricks to illustrate what's happening here. So this is the program I wrote. It's called HW5 server.cpp. This is the program that I wrote to implement that virtual class. So you can see that here, the class we just see in HW5 server.h, it defined a class called HW5 server. And now I create my HW5 server over here, and I actually provide the implementation for that. And then I can actually, I have to have this implementation, which is the dump to JSON. And then I indeed has this implementation down here. You can see that I actually have that implementation. Okay, so let's actually try to, okay, let me actually just do this, see what's the error message. By the way, I haven't tried it myself. Okay, now everything looks okay. So I'm going to actually modify this. Let me actually copy this to this keep. Let me keep an old copy. And I'm going to okay, so what I'm going to do is that I'm going to switch this. I said if define MMMN. Okay, just if define MMMN. Then I will do this. So essentially I block all the code. And if so I block all the code for that function. So essentially I have a code which I declare everything otherwise okay, but I don't have the implementation of this dump to JSON. Okay, now I'm going to make a clean, make again. Yeah. Oh, thank you. See, I'm getting there. I always forgot. I'm running out of battery. You don't have a lot of confidence about the battery technology. It will regenerate. Whenever it's the red all the way go to 0, it will regenerate energy from the air. No, I'm just kidding. Yeah. Thank you. I appreciate that. Okay, so now you actually see this. This is an error message. I appreciate that. Thank you. When I try to compile, let's look at what they said. When they try to link together, they actually say, hey, I actually want to get, wait a minute. Somewhere over here, it basically say there's no definition to some of the function. Let me actually even remove that one. That wasn't the error message I see the other day. Let me actually try to get rid of another one. So I already have this. And what happens if I get rid of this as well? Yeah, okay. So this one is what I'm expecting. If you don't have this implementation, it will say unimplemented pure virtual function method dump to JSON in this. So if you don't have that, the previous one is I actually have a definition, but I didn't have an implementation. If I remove even that definition, that it will actually complain to me saying that this is a pure virtual function. I'm sorry, you have to have that. If you don't have that, it will going to complain saying that it is unimplemented. Okay. All right, good. Okay, let's get back to the slide. So I hope you found this example, you understand the concept about pure virtual function, and the most appropriate use of the pure virtual function is that you try to have a cluster of classes. They're all derived classes, and you want them to share some common member function. And you want to make sure that everyone has their own virtual function. Then you're going to use the idea of pure virtual function to enforce that, because you define the interface, and somebody who actually used the code to follow the same project, they have to do that. That's the main reason. Okay. All right, so I'm actually going to go for my next topic. Let me get to, this is actually an error message, but I'm going to skip that. I already tell you this. This is the same thing about JSON RPC. They're using this. Okay, I think we have this already taken care of. Okay, so there's one more thing I want to show you before I start the new lecture in the exception, is that this is virtual inheritance. And the virtual inheritance, there is a vtable pointer. And the vtable pointer, this is actually going to be your homework assignment number 4. You actually can see that there is some address, and going there, you can actually grab it. But I want to show you this diagram. In terms of diagram, it really looks like this. It looks like this kind of data structure from the class object that's actually pointing to a whole table that's actually related to that particular class called vtable. And then over there, you will be able to find the right pointer. I really want to talk about this when we actually deal with homework assignment number 4, but I want you to alert to you for you to start reading is the textbook in the page 451 to 458, which is this section in chapter, I believe chapter 14 or chapter 13, I really forgot, is actually going to tell you about the cost of polymorphism. So polymorphism, the way C++ implement polymorphism is through the concept virtual function. And because of that vtable, that this section actually illustrate very nicely about the performance you're going to get hit by using polymorphism in C++. Okay, so that's what I want to talk about. I don't think the rest is okay. So now I'm going to go to the exception. About 10 minutes, so I can. All right, so I'm going to show you a very simple example. This is the basic. If you understand this slide, you pretty much understand the whole concept about exceptional handling in C++. It essentially has this what we call try and catch, and with a keyword called throw. So try define, there is a scope of code that you would like to be guarded by your exceptional handling mechanism. So essentially, you put anywhere in your code, you put a pair of curly bracket and put a try as a keyword in front of that, that means anything in between this one will be actually guarded by this clause is called catch. Okay, so by the way, you could have multiple catch. I will get to that more carefully. But here is a what I call a manual manually generated exception. Of course, sometimes you have a runtime error that it will actually throw some. Let me actually show you. This is a C++ standard exception. So this is what we call standard exception, STD. Let me just move this a little bit. Now you can see the whole screen. In C++, it actually have something called STD exception. So STD exception means that those are standard exception, and those are the things that you're going to generate exception, even you didn't ask for it. So for example, the standard exception including, you might know this, is a bad allocation. When you try to allocate certain kind of memory, that's actually going to have be a bad exception. And for example, you could have, say, let me see, overflow error, or range error, or underflow error. Those are related to what? Related to the array, or the range of the array, and they will generate that exception. So you can actually take a look at the code. And by the way, when you actually develop the your own customized exception handling class, then you actually inherit from a class. It looks like this. And then inside this class, pretty much you have constructor, destructor, and this is the function that you have to implement, is called what. What is a, you can call it, again, virtual function. It's a virtual function, means that if you want to display, by the way, this is a virtual function, but not pure virtual function. It's a virtual function, but it's not pure virtual function. Means that they have a default implementation here, just to clarify. But if you want to actually, what essentially is provide an error message. You can see that what is a what? What is returning character star, which is a string, which is actually the message about that error. So you can actually override this what. I mean, it's a virtual, so you can actually create a different what, which is handling the things you would like to handle. Okay, so that is the basic standard exception. Let's get back here. Okay, so if beyond those exception conditions, that's actually going to be created by the system, by the standard STD exception, those maybe 10 or 12 exception, you can actually throw as well. You can actually generate. For example, you say, I want to throw an exception when Little Red Riding Hood is endangered. Whenever Little Red Riding Hood is in the same record with a wolf, then I'm going to throw an exception. Then I'm actually going to do that, throw something. Okay, so you can actually do that. So that's actually a very nice way to think about programming now instead of become a algorithm driven, now we become event driven. Something happened, I'm not going to jump out to actually execute some code. I mean, it's just a style that you can actually think about this. So essentially what the flow it is that what we just say about exception handling is that you detect a particular condition is actually occurring in your program. Usually, this is some condition which is, for example, very unexpected, or it should never happen. So then you create, that's why we call it exception. And then, but in general program, you can actually throw anything, even it's not so exception, okay? But after that, you can throw, or it's automatically throw, and then it will be transfer, what we call the control transfer, means that it was the program that's actually running in the original flowchart. Now it's actually jump out of that and to another place. And by the way, after you've done this, when you're in the middle, you come over here. After you finish this catch clause, you're not going back over there. You're not going back to continue. Instead, you're actually just continue to execute the next line of code here. Okay, that's something I want to clarify. So number one, in exceptional handling, you're detecting something. Number two, you transfer your control to the catch clause. And number three, when you actually transfer control, you need to pass some information about that exception. And that is basically what we call the passing the argument. So let me actually show you some example. So here you can see that I have a program with multiple catch clauses. So I have a first catch clauses and the second catch clauses. So let me ask you, how will you differentiate? What's the difference between these two catch clauses? What's the difference between this one and this one? I mean, just based on the information I gave you on the slide. What's the difference between these two? The input argument type. The argument type. So this is what we call function signature. So catch is a function. It's not going to differentiate by the name because the name is always catch. So they're going to differentiate by the type. So you can have multiple catch as long as their argument are different, the type and the value. And then now I'm actually going to give you this program in the top. I have a two throw clauses here. One is throw a string, one is throw what's a tag index is an integer. So now you can guess which one goes to where, right? So essentially, if you actually go to the first throw clause, which is a throw a string. If you throw a string, it will actually be catch by the second catch clause because it match the type. And if you actually go for the first one, if you go to the first one, and then it will, if you throw an integer, it will actually come here. But after it finish, it will actually directly jump to skip the remaining clause. Okay, so they're not going to ask you the next catch clause, but they basically just catch one clause at a time. Okay, any question about catch? Okay, there's in C++, there is something called assert. By the way, anyone use the function assert in C or C++ programming? Yes, good. What's the difference? You see that using catch and clause, throw and catch versus using assert. Yeah, under what situation you use assert? You say you have seen assert, right? You have used assert? Can you describe a little bit under what kind of situation you decide to use the? Okay, right, okay, yeah. So basically assert saying that if this is a violated, and then after if it's violated, what will the assert do at that point? It will actually kill the whole program, right? It will assert meaning that if you do assert, the whole program, for example, if you have a Wordle program you assert saying that you open this file fail, then when you assert, it is going to kill the whole Wordle program immediately. But here, exception kind of give you the second chance that you're actually using this one to actually do some other thing. For example, you might want to clean up, you might want to save the state, you want to do a lot of stuff that's under here. That's a significant difference between using throw, catch versus using assert. Okay, thank you. Right, so the other thing which is important I want to tell you is that you can do this. For example, you can write a program that's actually have some problem with the malloc. If you actually, you can write a program. If you only allocate 1,000, it's not going to cause any memory allocation. But you actually can write a really huge array. You try to allocate a large memory, and then it's going to causing that. And then you can actually write a catch, exception, and. Remember what's exception? Exception is standard exception. So meaning that instead of letting the system complain, saying you have a malloc bug, I'm going to crash, you can actually catch over here and do something. You can actually, you see what I do? The e dot what? That's the function, the virtual function that the standard exception has. Okay. Okay, I'm going to do one more thing and then that's it because my time is up. The other thing which is important is that I can have multiple level of exception. I want to find a piece of code. I can show it to you. I missed that. I thought. Sorry, I lost that one. But I will continue on Monday. But what happened is that you could actually throw something being catched by one of the catch clause, and this catch clause can actually throw another one again to allow multiple catcher to catch the same exception. Okay, you all have a good weekend, and Brijesh should be here very soon, as I need to catch something very quickly.
For some records, can we have 0 things? Is that okay?
1 second.